Hello, my name is Peter Parfitt. Welcome to the new Brit workshop. The X-Carve CNC machine is a great bit of kit, but in the small workshop, the larger machine takes up quite a bit of room. And so I've devised a mobile cabinet that mine sits in. And when it's not in use, it's completely out of the way, protected from dust, and I can use the surface on top of it for other things. And this has only been possible because I've taken the plunge and decided to use gas struts in the fabric of the cabinet. And it's the gas struts that make the raising and lower of the CNC possible. Now, I'm hugely grateful to Metrol for supporting me in this particular project, particularly as I've never installed a gas strut before. I've got them or had them in cars and things like that, but never installed one. And on top of that, I've never designed a mechanism that's relied on gas struts either. So a huge leap of faith on Metrol's part, and I'm really grateful to them. Now, I imagine when most people order a new gas strut, they're just getting a replacement for one that's failed on a car or whatever, in which case it's a pretty simple matter. But if you're ordering gas struts for your own application, then there are a number of things you need to bear in mind. First of all, you need to decide how big the gas strut needs to be and how powerful. And you can look that up on the Metrol website very easily. And there are several dimensions which come into play. There's the barrel length, which is measured from here to here. There's the stroke, which is measured from here to the nearest side here of this threaded end. There's the overall length. There's also the amount of force that's needed to compress the gas strut. And if, like me, you don't know how strong the gas strut should be, you can get variable force gas struts. And that's what this is. Having selected the particular gas strut you need to then decide what type of fitting you want on the ends here and here. And there are all sorts of possibilities. And again, this is all clearly laid out on the Metrol website. Now for me, I need on one end of the strut an eye which then fits into a bracket like this, and that's going to fit on the underside of the table or part of my CNC platform. And at the other end I need something that fixes onto the side of the frame. So I've got a bracket like this, and there is a ball and socket joint arrangement here. Now my gas strut has got to have a ball and socket end on the rod end, that's the thin bit, that's the tube end here, but on the rod end I've got this ball and socket joint, but it's come with this particular ball fitting which I need to change because I need one that looks like this. And so I'm now going to show you how to swap this ball for this one. It's very simple. Now, if you look carefully, built into the socket side, there's a little safety mechanism. It's a spring clip. At the top here, you can see a little hole, and then down through there is part of the clip. And the clip then wraps round the body of the socket. And in order to remove this, I'm going to use a pair of pliers to do this. For me, it's the easiest way because of my arthriticness. I'm going to grab the end there, and I'm pulling this round, and you can probably see now it's come away from here. And that allows that then to drop down and away. So that's the safety clip removed. Now, in order to remove the ball from the socket, I'm just going to grab the thread here with a slightly bigger pair of pliers because that'll help me, and give it a quick twist like so, and that's out. And then installing the one that I'm going to use in here, there's no wrong way of putting this in, there's only one way of putting it in. Put it in like so and give it a jolly good squeeze, and you may have heard the click. So that's now in there, but I now have to return the safety clip. And again, I'm looking for the hole that goes all the way through, and I'm going to feed the pin that sticks up through the hole from the bottom. And then when it's roughly in place, I'm then going to swing this part round, and it's now clipped round the body. So that now is properly fitted. That's as safe as houses. And for me on the tube end, I'm just having a simple eye, which is going to fit in that bracket which I showed earlier. That's just got to be screwed on. That's reasonably tight. And then my bracket would go over here, and I'd then put a bolt through. Now, when you're doing your design with gas struts, you should build into your design the fact that the tube needs to be mounted higher than the rod. So in other words, it should be this way up, roughly. And that's particularly important if you've got a variable force gas strut, where at the top of the tube here, there's the little bleed valve. Now, in order to adjust the gas struts, you need to find the little hex key, like this one here. And if you look really closely at the top, of the tube end, you will see in this brass area here a little hole, and there's a grub screw in there. You very carefully put the hex key in, and you'll feel it lock into the grub screw. And then what you're going to do is to very carefully loosen it a tiny bit, and you'll then hear gas escaping. Now, whatever you do, don't, in the process of doing this, go and drop the hex key, because you have to be able to shut this off straight away. So there's mine, it's in now, and I'm going to release it probably by less than 1/8 of a turn. You listen. And I left it open for less than a second, and I've now shut it firmly. I've already done it on the other side, and you can now test each side to see how much resistance there is. And if it still needs more to be let out, you repeat the process. But don't leave the valve open for any longer than a second at a time. Now, my first design uses a bottom fixing on the frame here for the gas strut, and the top of the gas strut is fixed about here to the platform. You can probably see it on the other side more clearly. And this is how this works. All I have to do now is to push, and so it starts to go down. I've got something which represents roughly the weight of the CNC. However, as it goes down, so it gets actually pretty difficult to get it all the way in place, and yet at the top end it's very easy to move. So I've had another thought, and I'm going to try a different design. So my second design works as follows. I've now added a new piece, and it's this arm here. And this is critical in order to allow the gas strut to be fixed to the underside of the platform, and also be able to be compressed fully in its the platform's lower state. Let me show you. Now, this would be mounted on the other side, and I'm only doing this to illustrate. And there would be a similar one on the far side of the platform. In its compressed state, this arm would be in its lower position here, and there would be a backstop that stops the arm from going any further backwards. So therefore, the gas strut can react against this arm as though it was at a fixed point here. And this point is then just set up nicely, so it's attached to the bottom of the platform in its lower state. Then, as the gas strut pushes, as you're trying to raise the platform, it starts to do something like this. It's pushing against this bar quite successfully up to a certain point. And when it reaches its full extension, it can't go any further. But by now, the operator is able to take over and apply the very little bit of force that's needed to take it the rest of the way. And as the operator pulls it, the gas strut is fully expanded and is playing no part in the operation, and it pulls it up, lifting this arm up at the same time. Well, I'm afraid now it's confession time. You saw me demonstrating how I was using these stays with this gas strut, and I was able to move it around, it means there's no pressure left in there. And I'm afraid I was in the process of making an adjustment. I had a little Allen key in there. I just did a little like that, and the telephone rang, and I quickly closed the valve, or so I thought, and went and answered the telephone. And half an hour later I came back to find that this strut had no gas left in it. Lesson learnt. And here you can see how it worked. With the platform fully up, it was in a position something like this. And as the platform came down, first of all under operator control, this goes back to this fixed position here, and then it continues with the gas strut compressing like so until the platform is fully down. Now, I had one of these on both sides, and I must tell you that it didn't work very satisfactorily, because getting the two sides balanced as far as pressure went was tricky. And so I have a third way. Here is what I consider to be my final solution. I'm using the same arm extension which I showed you in the second design. I've got this block here which serves as a receiver for that arm to stop it going back any further, and the gas strut is mounted to the underside near the centre of the table. Now at this stage I'm not absolutely certain if I'm going to have a second gas strut side by side to make it absolutely symmetrical, or whether this will be satisfactory as the permanent solution with one gas strut. So I've got my final design of the struts being here in the middle, and you can see I've had to put a distance piece so that the draw runners, which will be fixed to the centre here, are not mixed up with the mechanism of the gas strut. And that was very simple to do. I made two pieces just like this. This is cut off here in order to accept this bracket arrangement here at the back, and it's cut off here in order to allow space for the strut. That's screwed in place, and then I can fix the draw runners onto this. You're probably able to see how I've constructed this. There are two struts, one on either side of the central cross piece here. They're fixed with a common bolt that goes all the way through, and there's a washer on the inside to help allow the free movement there. And at this end I've got a spacer, and this spacer is 30 millimeters long, and I've got a washer on the end of each end of it, which matches the thickness of the washers up here. And then at the very end I've got the ball ends for the two gas struts, and they of course go up through these two gaps here. Now I'm really pleased with this final design. I've left the gas pressure on the high side, and that means I need some mechanism for keeping it down when the machine is not in use. And so I've got this spring-loaded piece of wood at the back here. I release it like so, and then I can continue the lift of the whole platform. And when it's pushed down, it's then completely safely locked in place. Now, I'm really grateful to everyone at Metrol for putting their trust in me and helping me with this project. It works. I'm really pleased. Thank you very much. Incidentally, Metrol are also stockists of Accuride, and more of that later. Thank you very much for watching. Take care. Bye-bye.